Before Lemaitre, studies of the cosmos had largely focused on our own place within it, as well as observations to determine its composition and extent. The 13th century philosopher Sigurd of Brabant was alone in venturing the statement that the universe was eternal, with no beginning. His heretical views outraged the theologians of the time and earned him condemnation by the Pope in 1277. Rumour has it he was murdered with a pen, a symbol of the damage his ideas had done. Since then, no serious scholar had contemplated changing history, or a beginning. And so Lemaitre's calculations rocked the cosmological world. But they were not embraced by everybody. The idea was that the universe started its life a finite time ago in a single huge explosion, and that the present expansion is a relic of the violence of this explosion. This Big Bang idea seemed to me to be unsatisfactory even before detailed examination showed that it leads to serious difficulties. One respected but controversial astronomer, Fred Hoyle, railed against Lemaitre's expanding universe history, even coining the term Big Bang as an insult. For the implication of an expanding universe is that, at some point, it must have begun expanding, and at some point the universe itself must have begun. This, Hoyle confidently declared, was pseudoscience, little different from trying to justify the existence of a creator. The only reason, he said, that we were so attracted to this novel Big Bang theory was because the teachings of the Book of Genesis are so ingrained into our collective psyche. And yet, Lemaitre was quite happy to keep physics and religion separate. His mathematics didn't yearn for theological validation, and they were supported by real observations of the real universe, made by eminent astronomer Edwin Hubble just a few years later. From the Mount Wilson Observatory northeast of Los Angeles, Hubble had gazed tirelessly through the largest aperture telescope of the time, peering at some of the dimmest parts of the night sky. His measurements would prove conclusively the long-held suspicion that there were more galaxies than just our own Milky Way, but they would also show something that nobody had expected. Luminous objects, like stars, emit light as a result of the fusion in their cores. The colour and characteristics of that light depends on the temperature and the composition of the star, but it also depends on the star's movement. Just as an emergency vehicle sounding a siren will sound different when it's moving towards us or away from us, so too the light from the star will be altered when it's moving closer or further away. In sound, the phenomenon is known as a Doppler shift, and in light, it's redshift. The light waves emitted by stars moving away from us are stretched out. The same energy must now cover a greater distance, so the wavelength is subtly increased. In the visible spectrum, the longer wavelengths of light are coloured red to our eyes, and so receding stars appear more red than they actually are. Hubble wasn't the first to discover redshift in astronomical objects, but his observations at Mount Wilson did uncover a surprising truth. Every galaxy he studied was redshifted. Every single galaxy was moving away. Although at first this would seem to support religious notions of the Earth being the centre of the universe, the truth is stranger still. Hubble saw that the more distant galaxies receded much more quickly than those close by, and this could only be possible if the whole of space was expanding. These observations were a striking vindication of Lemaitre's mathematics and of the concept of a tiny beginning to our universe. In 1964, researchers at Bell Labs in Holmdel, New Jersey, were using a gigantic horn antenna to tune into radio waves bounced off some of the earlier satellites. The work demanded unprecedented precision, and the scientists went to great lengths to eliminate all possible outside sources of interference. But, despite their best efforts, their results were plagued with a persistent noise they couldn't eliminate. At first they thought it could have been the results of pigeons roosting in the shelter of the huge antenna, their droppings disturbing the signal. Or perhaps it could have been interference from bustling 1960s New York City, some 50 kilometers away. But eventually, it became clear that the noise wasn't pigeons or people. It was coming from outside our galaxy. It was a property of the universe which we now recognize as cosmic microwave background radiation. This radiation is a remnant of a time when the universe was very small and very, very hot, as predicted by Lemaitre's calculations. The expansion of space has since spread that radiation out, stretching the once intense heat waves into microwaves, with a background temperature of just 3 degrees above absolute zero. These radiation scars burned into the fabric of space are vindication of the truth of the Big Bang. The Big Bang Theory is now the accepted model for the cosmos, a picture of expansion over some 13.8 billion years. But there is still much work to be done, much understanding to be sought. The nature of the universe's first moments are still shrouded in mystery, and so many questions remain unanswered. What really was the Big Bang, and why does it break our understanding of the universe?